In front of us is the Houdini scene we left off with in the previous module. Let's neaten it up a bit. I'm going to select these three nodes and put down a net box, Control N, and let's name it prerequisites. That way we keep our scene tidy. Let's turn this building clusters node off and drop down a geometry node. Let's call it cityblock_sim. And in here, we will build our simulation for the city blocks. Before we do that, however, we're going to have to make a few changes to the things we've done before. I've had a look at the material we produced, and a few changes have to be made before we can continue. So let's do that first. Let's begin by jumping into our building clusters node and find our DOP simulation. Our DOP simulation is the blue node here, DOPNet1. Let's jump inside it. I'm going to expand our network editor a little bit so we have a bit more space. And let's have a look at our RBD packed object right there. We're going to have a look at our bullet data tab. No, actually, I'm going to expand this top window again. Let's go to the bullet data and find collision padding. As you can see, the collision padding is 0.02, and this means that the separation between objects is quite small. Let's zoom out and have a look from the top and run our simulation, see what happens. So you can see that these buildings, they fit quite snugly together. There is almost no space in between them at all, and our bounding boxes that we see, they completely envelop the actual bounding boxes that we have. So the blue box is the box that the DOP node creates, whereas our actual object would be a gray color as you would see them in SOP level. Let's set the collision padding to 0 and revert the simulation by pressing the back arrow. And now you can see what I mean. This is what our objects look like, and you can see when you rotate that the blue bounding box is actually exactly inside it, so they share the same faces. Now if I would set it to 0.1, you can see that the blue bounding boxes expand outside of our objects. This means that when the blue bounding boxes touch each other, the actual gray bounding boxes do not. And by expanding our collision padding, we can make sure that we have a bit of space in between our buildings. Let's leave this setting at 0.1, and please also make sure that shrink collision geometry is turned off. If you turn that on, you can see the setting underneath set to the same level, and if I increase the one here, it simply expands and contracts it by the same number. We do not want to do that, so turn that off. Let's also have a look at our PopVop, so expand the network editor again and find the PopVop. That's the first node right here. Let's jump inside it, and in here we have a small network, and to this network we're going to add a few things. Let me show you the reason first. Let's jump back up and back up again until we see our DOPNet, and let's find one of our clusters. I have houses cluster 3 selected. By hitting space G, I can zoom in on it, and if I rotate around it, I can see that I have buildings stacked on top of other buildings. So when we simulate these buildings and we pull them together to the center, what happens is some of them, due to the forces exerted on these bounding boxes, get pulled on top of other buildings. Now, of course, this is not what we want. In a real city, you would never see a house on top of a house, unless it's maybe a weird movie. But in our case, we do not want that. We want a realistic setting. So we're going to change this and make sure that doesn't happen. Let's go back to that PopVop. So we're going to zoom out, find our DOPNet, and find our PopVop. And that's right there. And the nodes that I'm talking about are going to make sure that our buildings are fixed on a Y position. So we're just going to hardwire that into our simulation. So let's drop down a vector to float, and also a float to vector. We're going to grab the initial P attribute and pump it into our vector to float. And we're going to go for the X and Z and pipe it straight into the float to vector. Now we should have a building height attribute. We can double check this by going up one level and another. And if we then middle mouse on DOPNet, we get a lot of attributes. But if we look at the 36 point attributes that we have in the top of our screen, we can see that the last attribute in the first line is building height. So the attribute's there, and we can use this. So let's drop down a bind node. And what we're going to import is our building height. This is a float value, so let's leave that. And it's going to be called building_height, as we have created it before. And what it now does is it pulls in that attribute for each of these buildings. And we're going to multiply this by a constant. So mul constant. And we're going to pump building height into the value of the multiplied constant. And now we're going to use 0.5 as a value in that multiplier. So we're basically halving the building height. Instead of a multiply constant, you could also use a divide, same result. And this value we're going to pump back into the y attribute. And once we've done that, we're going to pump the outcome of the float to vector into the position attribute. And this means that the y position of each building will always be half their height. We should have seen the blue bounding boxes jump in our screen because they've all rearranged themselves slightly to that new y value. And if we look underneath, we can see that we have them all sitting on the floor. This is what we want. This also means that the simulation will not be able to change the y position, so no more stacking of buildings on top of each other. This means we can make another change. Let's jump back up outside of our pop-up. And if we look to our left, we have our static object, and that is the floor that we have underneath here. This floor we use to make sure that the buildings sit on top of it, but because we're fixing the y position, we really no longer need it. Rather than removing it, I'm just going to break this connection, but just in case I might need it again, I'm just going to leave it there. It's not going to do anything anyway. So let's do that. Let's jump back into a pop-up and also fix the force that is putting those buildings on top of each other, or was. And let's just multiply our force after the subtract times 0.1 so that we have only 10% left. Another multiply constant, and the value in there is 0.1. And that's just to make sure that the forces are not too strong and that our city block simulation will run successfully for every block. So let's have another look. Let's go up one level and again. Let's visualize our copy one node. And now if we look from the top, we can see that we have buildings very snugly sat together. There is this very elongated building right here. These two, for example. Let's pick my primitive selector and pick this one or this one. You can see that their top faces are intersecting. Now, this is not a good starting point for contracting the buildings together and creating clusters. Let's see our switch node and make sure that they are set to the incoming commercial buildings. So we have import commercial, and that line is thick. So that means we are seeing the commercial buildings, obviously, as they are inside our viewport. And let's just make sure that we give these buildings a bit more space. So as we've done before, let's just look at our grid size again and increase the size of it. So it's now 190 by 190, but I'm going to make that 300 by 300. The amount of rows and columns I've left the same. We also no longer need to increase the ground plane size because we've fixed our Y locations at 1. So no matter how big we make this grid, that's all fine. However, we might need to do this in the future anyway and pull our ground plane back in. So just in case, make it a bit bigger so it's not something that we can forget. I like building in these little securities for myself. There is so much going on, so it's easy to forget one part. So once that's done, that's that fixed. Let's visualize our DOP import 1 and have a look at what we get. I can see that the grid spacing is a lot smaller than we defined. So first, then again, select the DOPNet 1 and reset the simulation. That should then update everything inside. Let's zoom out a bit. Now, if we press play, we should see our simulation going. It's a bit slower than before because we've set the force that attracts the buildings together to be smaller, 10% of what it was. Let's zoom in a bit. If we rewind a bit, say to frame 150 or something like that, and we play, we can see that the buildings are quite moving. They're still very busy. What I would like for the buildings to do is to settle. So for that, we need a bit more frames. So let's open our global animation options and set our end range to 600 and hit apply. And that now gives us a bit more space to simulate on. So the longer we simulate, we should see them calm down. And by frame 600, we should for sure have a city block that we can work with. Let's set our timeline to 600 and have it simulate all the way there. After you've adjusted your timeline to 600 frames, you're ready to join me in the next clip where we'll make a few more changes.